All right, here we've got a rock being thrown from the top of a 30-meter high cliff, but a little twist to this question, it's thrown downwards at an angle of 30 degrees down from the horizontal, and its initial velocity is 8.0 meters per second. So this angle right here is 30 degrees, and then of course the hypotenuse, which is our original velocity, is 8 meters per second. So as usual, we want to break our original velocity down into its x and y components. Now its x will be 6.93 when you do cos. So 8 cos 30 is 6.93. And when I find the y, which is opposite to the angle, we're going to use sine. So it'll be 8 sine 30, which is 4 meters per second. Now the thing is with the y though, it's down. See how my red arrow is pointed down? So I've got to make sure I put in -4 for my initial y velocity. Now, populating the rest of the list, it wants us to find the range, which is dx. So that's what we're looking for. I don't know time. dy, I don't know v final in the y. dy is my displacement vertically. And if I start at the top of the cliff and end down below, my final displacement will be -30. Got to watch the signs. Don't know time. My acceleration, as usual, is -9.8 meters per second squared. Now, once again, I want to avoid that quadratic formula. Once I know that I have an initial angle on my velocity and a vertical displacement of some sort, we call that a type 3, and the math gets a little bit trickier. So to avoid the quadratic, I choose to solve for v final in the y first. So I don't know time, so my first equation that I'm going to use is this one. So v initial was -4. I've got to square it, so the negatives don't really matter in that case. My acceleration was -9.8. My displacement was -30. So when I crank out the right-hand side, it becomes 604 is equal to v final squared. So the only thing left is to square root both sides, and I get a final velocity of 24.6 meters per second. Now remember, when you square root anything, it's plus or minus. Now look at the question. If we look at our picture, the object starts up top, and then it follows a parabolic arc and hits the ground down below here. When it hits the ground, it has two components of the velocity, or I should say just before it hits the ground, it has two components. It has an x component, which never changes. It's going to be 6.93. It's always 6.93 at all points in the path. But the y component should be increasing, and the y component is what we're looking for. Notice that it's down, so I have to choose the negative for my v final in the y. So my final velocity in the y will be -24.6 meters per second. Now we want to pick a different equation to solve for t. And I like this one. V final is v initial plus at. So if I solve that for t, I'd subtract a VO from both sides and then divide by a. And I end up getting -24.6 minus -4. Got to watch your signs. Very important. Divided by -9.8. And when I do all of that, I end up getting a time of 2.10 seconds. Now I can transfer that across to my x. We're trying to find dx, so the last step is fairly simple. Vx was 6.93 meters per second, and my time was 2.1. And when I multiply those things together, I get a range of 14.6 meters. So that's how far away from the cliff it'll end up, 14.6 meters away.